Hello everyone, welcome to my channel Inam Center of Excellence. If you are here to master the topics of physics and mathematics at the higher secondary and secondary level, then certainly you are in the right place. In this session today, we are going to explore the topic of one of physics for class 12 students, and that is electrostatics. So to begin with, let us try to understand few phenomena that we observe day in and day out. The lighting that is happening in the sky. When you rub a comb, you bring in close proximity to tiny bits of paper, you find those tiny bits of paper getting attracted. When you walk over the carpet and then you touch a knob, metallic knob, you find a shock. So these phenomena, when you perform certain operations, then this property comes up. However, before rubbing the comb, we didn't find the tiny bits of paper getting attracted. So what exactly happened? What is the physics behind it? So to understand this, let us understand electric charge. Let us understand electric charge. What is this electric charge? This is an intrinsic property of any fundamental particles that make up the object. So this electric charge is intrinsic property and this intrinsic property is as fundamental as mass. We know mass, right? The quantity of matter. So for any body, any particle to exist physically, it has to have a mass. So experiments have shown that this electric charge is as fundamental as mass. So this exists everywhere. These fundamental particles exist in every particles that make up the matter, which make up the object. All right, so the discovery shows that this intrinsic property, and we'll restrict our discussion to those intrinsic particles, those intrinsic properties which are in those fundamental particles, which at the atomic level, famously known as protons, neutrons, electrons. All right? And we know this, the mass of proton is 1.6723 times 10 raised to the power minus 27 kg. Neutrons, another fundamental particle that is present at the atomic level, has a mass 1.675 approx times 10 raised to the power 27 kg. And then we have electrons, which has a mass 9.11 times 10 raised to the power minus 31 kg. So a question comes, if this intrinsic property, which is electric charge, is as fundamental as mass, then why it's not available every time? Why it is not at the upfront? So we need to understand some basics of it. And that the experiment says that these electrons, these particles, protons and electrons, these are those particles which have a charge, which have the electric charge. However, these make up in such a way in an atom that it is a balanced, it's a neutral atom. Neutral atom. So these make up neutral atom. Why? Because the charge, the electric charge is balanced. What do we mean that? Now this property, electric charge, is there in proton, is there in electron, but this particle has no charge, neutral. The number of protons and the number of electrons, if it has a charge, then that charge in total, the net charge, if it is equal and opposite, if it is equal and opposite, by opposite we mean, with the mass we find that there is no negative mass, right? Mass of proton has a value There's no opposite nature to the mass. However, this property, which is electric charge, has this characteristic that it is found that these are available in opposite nature. These are of opposite nature. Opposite nature. To understand, we say one is positive, one is negative. So by convention, it's taken protons to be positive and electrons to be negative. And we call this charge as elementary charge. Elementary charge. Elementary charge. And the value for this elementary charge, the experiments have shown that it's 1.6 times 10 raised to the power minus 19 coulomb. So let's understand this. What is this coulomb we are talking about? And what is this value? So this value, this quantitative value, gives an idea that it has a magnitude and it has a unit, coulomb. So how this 1 coulomb is defined? So let's understand that as well. 1 coulomb. 1 coulomb of charge. 1 coulomb of charge. And what is this 1 coulomb of charge? This 1 coulomb of charge is that amount of charge when a body has this 1 coulomb of charge, when two similar particles are placed with a separation of 1 meter, it experiences a repulsive force of 9 times 10 raised to the power 9 Newton. If you place two similar charge, if those two similar charges has 1 coulomb of charge and those are placed at a distance of 1 meter, and if they experience a repulsive force of 9 times 10 raised to the power 9 Newton, then we say that those two charges have 1 coulomb of charge. That is what we are referring to here, coulomb. So 1 coulomb of charge is that amount of charge, if it is there in the body and those two bodies are placed or particles are placed in a distance of 1 meter, experiences a force, a repulsive force of 9 times 10 raised to the power 9 Newton, then we say that this amount, the quantity of charge in those particles has 1 coulomb, 1 C. So 1.6 times 10 raised to the power 19 times 1 coulomb. This is the charge of proton as well as electron in an atom. So by convention, we take this proton to be positive, and by convention, we take charge of the electron to be negative. And if the value is same, which is 1.6 times 10 raised to the power minus 19 coulomb, but the nature is different. One is positive and one is negative. So if it is equal and opposite, there is no net charge. And as there is no net charge, we say the electric charge or the net charge of an atom, net charge of an atom is balanced. So for a body to have a charge, we need to create this imbalance. If you are able to create an imbalance, the body will exhibit the property of having a charge. That is, either it would get attracted or either it would get repelled. So this is where we say that the body has acquired this property, which is the body has got a charge, and we say the body has been charged. So suppose if you take a glass rod and you take a silk cloth and you rub it, you would find that the silk is getting another kind of charge, which is negative, and the glass rod develops a positive charge, that is net charge. So what exactly happened while rubbing, while performing this operation? The electrons from one body gets transferred to another, and this creates an imbalance. Eventually, this ends up having a body which is charged. So this balanced condition now resulted in creating an imbalance and that what we call that the body has been charged. Now, having understood this, let us now go through a few of the properties of electric charge. So until now, what we have understood, let us quickly recap. We have understood that every body, the matter, is made up of fundamental particles, and those fundamental particles has mass as well as electric charge, as fundamental to as required to be in physical form, in physical existence. The value of this charge, experiments have shown, that is it's 1.6 times 10 raised to the power minus 19 coulomb. It's known as elementary charge. So the magnitude of proton, if it has, a body has at the atomic level just one proton, and it has one electron, or it has multiple protons, number of electrons, whatever, this value gets multiplied. But if it is equal and opposite, then atom is going to be neutral, and we say that body is not charged. So if you perform an operation and you create an imbalance there, then eventually the body ends up having a charge. So we get a body to be charged in this way. So let us now understand again what are those special properties that this electric charge exhibits. So we'll try to understand now the properties of electric charge. Properties of an electric charge. So the first property is like charges repel and unlike charges attract. So if you bring two bodies, if they are positively charged, the other body is also positively charged, or both have negative charge, they are going to repel in close proximity. If you bring the opposite nature together, it's going to attract. So like charges repel, unlike charges attract. Second property. These electric charges which are there. So the second property that we can find, next property that we can discuss is charge is quantized. Charge is quantized. This property essentially means that this charge that we are talking about, which is electronic charge, E, elementary charge, this charge, say for example, we take an example of electron. So electrons, this exists as whole number multiple. This exists as whole number multiple of this elementary charge, which means that electrons cannot be in fractions, right? So electrons cannot be in fractions. So if you are talking of the electron, it is as a whole, and the electronic charge is elementary charge. So whatever charge it has to have, it has to be whole number multiple of this elementary charge, which is E. So for example, a body could be of plus 10 elementary times elementary charge, or it could have minus 10 elementary charge. It cannot have 3.5 times elementary charge, or it cannot have minus 2.75 elementary charge. It has to have whole number multiple of elementary charge. Mathematically, the same thing we can write in this way. So the net charge, that is net charge, this is equal to n times this elementary charge. Now, where this n could be, depending upon the nature here, it could be, the elementary charge could be negative, it could be positive, negative in case of electrons, positive in case of protons, right? So mathematically we can have this equation, and this n is equal to plus minus 1, plus minus 2, so on. It has to have this. Take up these values. It cannot be in fractions, 3.5 or minus 2.75. This whole concept comes under that charge is quantized, or which is known as quantization of charge. So let us take an example. Suppose a cloud. Suppose if we have a question, a cloud has in due course of time developed positive 24 coulomb of charge. It has started neutrally, but it has gained eventually plus 24 coulomb of charge. So if a question is, how much electrons were removed from that cloud to get that cloud value of charge as positive 24 elementary charge? So let me write that question. Suppose the question says here, suppose a cloud started neutral, but eventually developed plus 24 coulomb of charge. So the question is, how many electrons were removed from the cloud which caused it to develop positive 24 coulomb of charge. All of you, can you try this question? I'll give you 2 minutes, just try this question and then we'll move ahead. Write in comments if you have the answer for this question, everyone. Okay? All right, so let's discuss the approach. So how can we understand this? If it developed 24 coulomb of charge, which means that the number of electrons that were removed, let the num n is equal to number of electrons removed, right? So if number of electrons were removed and it developed 24 coulomb of charge, so total charge that was removed, so net, the total charge that was removed, and that charge that should be electrons when electrons are removed, so that is minus 24, right? Minus 24 coulomb. And this should be equal to number of electrons times minus of elementary charge. Elementary charge is electrons, so we get this. Therefore, n is equal to 24 divided by elementary charge, which is 1.6 times 10 raised to the power minus 19 coulomb. So if you are going to evaluate this, you will get the answer of for number of electrons that were removed to get this charge developed in the cloud. And you would find this comes out to be around 1.5 times 10 raised to the power 18, maybe 20 electrons, I think. 20 electrons. 1.5 times 10 raised to the power 20 electrons. Are we clear how we apply this equation? So we are fundamentally using this equation, which is Q is equal to N times E, to solve this problem. Are we okay until this point? Great. Now let's try to understand another very important property, which is charge is conserved. So in the transference of charges that are taking place, to get a body charge, the transfer is taking place, and that transfer is in an isolated system is constant, right? So third property is charge is conserved. So in an isolated system, number of electrons which are going from here and there, it's nowhere getting created or destroyed. It's just the electrons getting transferred from here and there. So that essentially means that charge is conserved, the conservation of charge. So what are the examples? Pair annihilation, pair creation, and pair annihilation. Annihilation and pair creation. These are few examples that we can talk about when we talk about charge is conserved. So pair annihilation, pair production. So the third property that we can have here is charge is conserved. This essentially means that charge cannot be created or destroyed. So the number of charges which are getting transferred in the isolated system, it remains constant, right? So charge cannot be created, neither it can be destroyed, it gets just transferred, right? And what could be the example? Example could be pair production, and pair annihilation. So this could be particles, if they are produced, particles when meet, they annihilate. So this is in an isolated system. So this means that in an isolated system, charge conservation is observed. So this is one of the property that is charge conservation. Another property is very important, which is charge is non-relativistic. So what does this mean? We know this mass of any body, this mass would change, and this change depends upon the speed, right? And we have a famous equation that this mass is equal to mass at rest divided by under root 1 minus v square by c square. C is velocity of light and v is the speed with which that particle is traveling or the body is traveling. So the mass can change. The mass changes, however, charge does not change. So it is non-relativistic. It is not relativistic. Mass is relativistic. That is another very, very important property that we have. So we can take note of this, that charge is non-relativistic. Another property is the charge at rest exhibits certain interesting phenomena. And also, so before we move on to that property, let us discuss this, the fifth, which is charge, additive nature of charge. Additive nature of charge. So which means that charges could be added up. So this charges are added up. Charges can be added up algebraically. So this is additive nature of charge. Another property, charge at rest, this produces electric field. And charge at, or moving charges produce magnetic field. We'll be studying this in detail in other chapters, but this is the property, the charge when it is at rest, it's going to produce electric field. What is electric field? We'll come to know about later on. Moving charges, it produces B field. Now, another interesting aspect is that accelerated charge, right? Accelerated charge not only produces electric and magnetic field, but it also radiates electromagnetic energy. So this is another aspect related to this, which is accelerated charges not only produce electric and magnetic fields, So this is the notation we use. We use the notation electric for E. This is denoting a vector quantity. B, magnetic field. So if it is acceleration, in a mode of acceleration, it not only produces these two, but also radiate electromagnetic